So now we're going to talk about graphing a function that has not only a amplitude change but also a period change. So let's see what that would look like. First of all, we can see that the amplitude, the absolute value of that, is 3. So now we're going to have maximums here at 3 and minimums here at -3. We also see that we have a period change, so that's going to be 2 pi over the absolute value of 2. So the period now is pi instead of 2 pi. So if we were to, we know we have on the parent sine function a max at pi over 2 and a min at 3 pi over 2. We know we have a 0 at pi and at 2 pi and at 0. So we can very smoothly draw our parent sine function without any trouble, and it does go on in both directions, so we would need to show that. But now this function is going to accomplish what the parent function took 2 pi to accomplish. It's going to accomplish it in a period of pi. So let's just graph the sine of 2x. We'll worry about the amplitude change at the very end. So now where the parent function has a 0 here and here, now what happens at 2 pi is going to happen at pi, and what happened at pi is going to happen at pi over 2. So it will have a 0 there. It's going to have a maximum halfway in between, which would be at pi over 4. So it would have a maximum here, a maximum of 1, and then it's going to have a a minimum in between pi over 2 and pi, roughly at 3 pi over 4. So we would have a minimum here. So now this graph is going to look like this. We're going to go up here. We're going to have a 0 at 2 pi. We're going to have a minimum at roughly 3 pi over 4. And you can see what that shortened period does for the graph of the function. And now finally, we'll pick up and we'll graph this function, because where this function has a maximum of 1, this one has a max of 3 and a min of -3. Let's see if I can get those points to stay there so I don't know why they want to disappear. They do though. So we're going to have the same zeros, but we're going to have a max here. We'll have a 0 at pi over 2, and we're going to have a min here. So that function would look like this. Here is the graph of y equals 3 times the sine of 2x. So it's very helpful to start with the parent function y equals sine of x, and then handle the period change based on how we know sine behaves, and then handle the amplitude change. Now there's one last change I want to talk about as far as graphing is concerned, and that is a horizontal shift. Horizontal shift happens inside the parentheses with x. In trig functions, the horizontal shift has a new name. It does the same thing, but instead of having a horizontal shift, we say that these trig functions have a phase shift. So let's see if we can handle this phase shift. The first thing we're going to do is we're going to draw the graph of the parent sine function, and it looks something like, and this goes down to -1 roughly at 3 pi over 2 and comes back up here. So there's the parent sine function, y equals the sine of x. So now let's pick a different color, and this says that every point in there is shifted a distance of -pi. Remember, this is x minus negative pi. Let me write that again so you get it in your notes right. The sine of x minus a negative pi. So this is a distance of pi in the negative direction. So we take all of our points and we take them to the left a distance of pi. So this point is now here, and this point is now here. So what we're going to do is this part of the graph is now going to be right here. We have a minimum, if I can draw it straight, we have a minimum of -1 because what was happening here is now happening a complete shift of pi to the left. And then if we were to continue on with the parent sine function, this piece, which has now been shifted to the left, would look like this. So this piece gets shifted a distance of pi to the left, and so it would look like so. So the red graph actually shows y equals the sine of x plus pi. So everything we know about those translations that we brought with us from our other functions, now we know that just, if we have a function and we add a constant to it, then that is a vertical shift up a distance of c. If we subtract a constant to it, from it, it is a vertical shift down a distance of c. If we have some value inside, that is a shift to the right a distance of c. This would be a shift to the left a distance of c. And if we had some sort of value out here, if a was larger than 1, that would be a stretch. If a was in between 0 and 1, that would be a compression. All of those things that we know from our other parent functions and their transformations and translations, that is true here for these trig functions as well. The only thing we have to pay attention to is now we have a period, and we could have a change in our period, how quickly the functions cycle through their repetitive behavior. That is something that we've got to pay attention to that we didn't have to pay attention to on those other functions, those other parent functions. So I think we'll stop here. That's enough information about the parent sine function. So come to class next time and we'll practice graphing some of these functions.